Okay, might as well start a minute early, why not? Takes me a minute just to set everything up anyways, right? Okie-doke, get this laptop ready. Good morning, everyone that actually happens to be awake. Hold on. Maybe. There we go. Wait, stop. Here we go. Alright, I'm ready, I swear. Okay, it's 8 o'clock. Welcome to a pre-cal lecture today. It is Wednesday, April 29th. And yeah, we've got a lecture for today. So high school pre-cal, we are going to wrap up here in the next couple of weeks. We have, including this one, we have 3 lessons left. And then we have our last test, and then that's it. So we're getting close to the end. Dual credit, you have your final exam in 5 days. So you're going to be done with me in about 5 days. So that's great. Yep. If you haven't heard, they are going to have a virtual graduation. I'm not quite sure how that works, but I mean, I'm sure they're just going to read a bunch of names on a big web conference, and you know, they can't hand you anything, but they'll make all the announcements about who won what. What else? This Friday, they're going to do top 10 celebration on Garth. So it's a little drive-by with your car thing. What else? Let's see. I think that's all the info I've gotten so far. Okay, so I guess before we do this, before we do our pre-cal lecture, one thing for dual credit, those of you that happen to tune into this video, your course evaluations are due by the end of the week. So be sure y'all are getting that done. And if you are participating in the extra credit assignment, the rough draft of your paper and your presentation is due tonight by midnight. So turn that in. I'm going to give you feedback on that the next day or two, and you need to fix it before the final presentation next Tuesday. Okay, let's do a lecture. So we are going to learn about polar coordinates today. So high school pre-cal, this is your intro to polar coordinates, which is just a different coordinate plane that we use in calculus. We're not going to get too far into it in this class. I mean, you have a whole unit on it in calculus for those of you that are going to calculus. Those of you that aren't, we're going to do a pretty basic rundown of it. We're going to do the surface level version of it. And after this, we'll learn parametric, and then you'll be ready for your last test of the year. So, okay, so first of all, what is a polar coordinate? Well, it looks a little bit like this. So let me show you. Here's a couple of example problems. So normally when you have like an axis, a set of axes, we're used to it being x comma y, where the first number tells you how far left and right to go, and the second number tells you how far up and down to go. So if I ever give you the coordinate point 2, 4, you know that that means that that's an x coordinate and a y coordinate. So you go right by 2 and then you go up by 4. And that represents that one dot up there. So now instead of telling you what polar coordinates are instead of how far left and right, comma, how far up and down you go, it's going to be r comma theta, where the first number is the how far away from the origin you are, kind of like if you had to draw a circle, what would the radius of the circle be? That's what r stands for. And then theta is from 0 degrees, which we know 0 degrees is right here. From 0 degrees, how far do you turn? So, for example, for the first one, we have 3, 105, and your instructions on your assignment, the one that I posted, is just going to say, you know, plot the particular coordinate point. So just to give you a preview, so you plot the point with the given polar coordinates, and then you see I copy-pasted the thing that's on your homework. So not a whole lot of work to show for the first one. In fact, it should be a pretty short assignment for you. So we have 3, 105. So ironically, you actually read these backwards. So figure out where you're facing with 105 degrees first, And if you'll notice, this isn't exactly like your unit circle because they give you more lines than necessary. Every single mark right here is 15 degrees worth. See, 15, 30, 45, 60, 75, 90, and it goes on and on for the rest of the circle. So 105 would be right here. There we go. Here, let me erase all these other marks. Okay, so you're facing that way. Now, all polar things for this entire rest of this unit, pretend you start on the origin. So you're standing on the origin, and then turn towards 105 degrees, and then you're going to step out 3 spaces worth. So 1, 2, 3. Or you can just follow this. You see how here this tells you, if you just follow that 3 circle all the way around, that's a radius of 3 away from the center. So that would be that coordinate point. And so for the beginning of this, you just need to identify different coordinate points. We'll do graphs next week, but that's all you need to know. And then -2, so how do you deal with negatives inside of polar? Well, in rectangular, which is what we call up there, in rectangular world, negative x's mean you go left, negative y's mean you go down. So what a -r means is you just walk backwards. So figure out where you're facing and then walk backwards by 2. So in the first example, -3 would have been, +3 is here, so -3 would have been back here. 1, 2, 3. Like that. And then negative angles, we already know what that means. That means go clockwise instead of counterclockwise. So remember, this is the second one is r comma theta. You actually do the theta first. So where am I facing by going -15? Well, if this is 0, -15 is right there at 345 degrees. And that's behind my face. Hold on. So -15 is right there. And so if I'm standing in the origin and I'm facing towards that particular direction, I want to now go -2. So +2 would have been here. So -2 is going to be back here. So that's the answer. I guess I'll erase that mess. Okay. So that's how you deal with a -r. That's how you deal with a negative theta. Do I need to make it clear what the answer is? There's your answers. All right, let me put my face back. Whee! All right. Let me make sure I'm not completely ignoring chat. Okay, we're fine. Moving on. So rectangular coordinates. So how do you change from polar coordinates back into rectangular coordinates? So right here, 4, 210, that is a set of polar coordinates. Now I want to think about how that looks if I were to change it back into x, y. Because if you look back here, those answers that I gave are telling you a certain place that exists in space. The origin is still 0, 0 in both worlds, in x, y, and r, theta. So, for example, the second one we did, -2, -15 degrees. If I were to relate that back into x, y world, from the origin, I went left by some amount and I went up by some amount. The question is, how do you actually figure those numbers out? Well, we're actually going to use these 2 equations, and these come from just right triangle math that we've done already. So let me explain where these 2 things come from. So if you just have any point that exists, remember the r is how far away from the origin you are. The theta is how far away from 0 you've turned. And now I want the x coordinate and I want the y coordinate. This actually perfectly reflects a right triangle. So that means SOHCAHTOA applies to everything. Pythagorean theorem and SOHCAHTOA apply to everything that we do with polar and rectangular things. So I mean, next slide we'll learn about all that stuff. But if you have r and theta, how do you find x and y? Well, cosine of your angle is equal to adjacent over hypotenuse, like that. So all you have to do is just multiply both sides by r. That cancels, and x equals r cosine theta. That's where the first equation comes from. Similarly, sine of theta is equal to y over r. And then you just multiply the r over. So that's the theory, or that's the logic behind why you have those two things. So if you have 4, 210 degrees, we have a rough idea of that, what that looks like, right? 210 is going to be somewhere over here, right? 210 degrees. In pre-AP, you're doing the exact same assignment, except you have radians instead of degrees, just like normal. So 210 degrees, I'm facing somewhere down there in quadrant 3, a little past 180, and you went out by 4 spaces. So how do you actually get the real coordinate? I'm guessing it's going to be like somewhere right there. Obviously, that's not the answer yet. So I have r, I have theta. I can plug it into there. So x equals 4. Whoa, that's a terrible looking 4. What in the world? Okay. 4 times cosine of 210. Well, guess what? I know what. Oh, I almost spilled all my coffee everywhere. That would have been great. Let's move that out of the way. Okay. We have our unit circle to figure out what cosine 210 is, because if you look at the answer key for this assignment, you're going to need exact answers for everything. So you can't just type this into the calculator. So cosine 210 is actually negative square root of 3 over 2. So x equals negative 2 square root of 3. Which ironically, even though you're not supposed to type this into the calculator, you don't necessarily know how much 2 square root of 3 is. Like, you don't know what decimal you're supposed to be, so you're going to need to type it in anyways to get a rough idea. Your y coordinate is 4 times sine of 210. And then sine of 210 is negative 1/2. So y is negative 2. That one's easier to find. So I know the y coordinate's negative 2. How big is negative 2 square root of 3? So it's roughly 3.5, like negative 3.5. So whenever you want to figure it out over here. Let's erase that x now. So negative 3.5-ish, and then negative 2. So there's where it would have exactly been in polar coordinates, and now I know that the coordinate point is negative 2 square root of 3, comma, negative 2. So that's your rectangular coordinate that corresponds to that polar coordinate. This and this are describing the exact same place in the world, if you want to think of it that way. Okay. So that was polar to rectangular conversion. So now obviously we need to go the other way, and we need to do rectangular to polar conversion. The only tricky part about this is figuring out theta. And again, let me try to illustrate what it means by that. So we have a rectangular coordinate, so same drawing as before, except now we know the x and the y, and we want the r and the theta. So same 4 pieces of information. Well, if I know x and y, I can figure out r by doing Pythagorean theorem. So that's what all that first equation is. It's just Pythagorean theorem. I square rooted ahead of time. For theta, I know that tangent of theta is opposite over adjacent. Oh, and I'm writing behind the overlay. But tangent of theta is y divided by x. But that would only give me that angle if I were in quadrant 1. If I go over here to quadrant 2, and if I do tangent equals opposite over adjacent, that gives me this angle, but that's not actual theta. Theta always starts at 0 degrees. So I would have to do 180 minus whatever my calculator gave me to find the true angle. So that's why I've marked a little theta prime, is what we would call it in calculus. So theta prime is the inverse tangent. There's absolute value bars because of the fact you have to manually figure out where theta is yourself. Your calculator doesn't magically just tell you, oh, this is going to be 210 degrees because you have to be in quadrant 3. It doesn't know whether the y is negative or the x is negative when you put a negative on the fraction. There's this whole thing, and we don't cover it nearly as much as we should in high school pre-cal, but there are rules to the domain of inverse tangent that we're not going to cover today. Essentially, you've got to figure out the theta by yourself. The inverse tangent part will tell you the reference angle, but you have to figure out what quadrant you're in and use the reference angle accordingly. Okay, so let's get this answer first, and I'll elaborate more on what other tricky versions might happen. So negative square root of 3 over 2, comma 1/2. So I know that that's going to be left by some amount, up by some amount. I'm guessing I'm in quadrant 2. I'll put a big question mark here because I don't know. But I know for a fact I'm in quadrant 2. All right, so let's find my r. So this is square root of negative square root of 3 over 2 squared plus 1/2 squared. Well, that's square root of 3/4 plus 1/4, which is square root of 1, which is 1. So my radius is 1. No, okay. R equals 1. Now what direction am I turning? So inverse tangent of y divided by x, so 1/2 divided by square root of 3 over 2, and I'm ignoring the negative because there's absolute value bars there. Another way you could do this is just open up your unit circle and figure out where those x and y coordinates are. Just look for that coordinate point on your unit circle. But this ends up being square root of 3 over 3. And tangent is square root of 3 over 3 at 30 degrees. That is not my answer for theta. So if you look at the rectangular coordinates, I went left and up. So that means I'm in quadrant 2 somewhere. This 30 degrees corresponds to that angle right there. But that's not the angle that's the answer. The angle has to start from 0 degrees. I want to know that answer. So because my reference is 30, I should be using 150. So my actual theta is 150 degrees. And honestly, out of the entire worksheet, that's the only, or I won't say that's the only, that is the trickiest, whoa, drop my pen. That's the only trickiest part. I can't talk right now. It is the trickiest part. You might have some trouble with some of the other stuff, but from my experience, finding the angle from rectangular to polar seems to bother some people. And the best piece of advice I can give is just figure out which quadrant you're in, and that tells you whether you add to 180, subtract to 180, subtract from 360, etc. The angle you get should make sense in terms of what quadrant you are in. Hopefully that helps. And that's it for this intro lecture. So this is just starting with polar. That's all there is to it for now. We're going to do graphs of polar next week. And then you have this assignment. And then remember, you still have solving trig equations due today. Oh boy. 52 of you still need to get this done. But yeah, this one will be due May 5th, which is a Tuesday. Which for those of you doing extra credit, this is the same day we're doing our Zoom presentations. So please don't overload yourself with work just for me. I've been trying to give you roughly 6 to 8 days for every single assignment I give you. I mean normal. Extra credit has been every about like 4 or 5 days, something like that. But you're almost done with extra credit. Okay. I don't see any questions in chat. So, hey, we actually have people that are logged in and not and didn't get a drop. All right, let me open my little folder here. And you know what? We have someone that wins by default because everyone else has won. There you go. Congratulations, I will fix your grade. You get a free drop today. Thank you for tuning in and actually waking up in the morning. All right, let me mark this real quick. Have y'all ever noticed whenever we do a live stream, there's always a couple of random people that just lurk on the channel that are like Twitch people that don't do anything? It has taken me this long to figure that out. Yeah, apparently there's just some accounts that just lurk on any live channel. I guess just to give people views? I don't know. I mean, I'm okay with it, I guess. Okay, so I don't see anything in chat. I don't have anything in email. I think I've addressed everything I needed to talk about. So extra credit, turn it in tonight. Your rough draft. Pre-cal solving trig equations is due tonight. Make sure you get that turned in. And that is all I have for you. So thank you so much for tuning in, and I will see you tomorrow.